All right, ladies and gentlemen, what's up? And welcome to another day, another day, another day. We're about to go, so let's go. So today we're getting started. We're actually continuing with Eloquent JavaScript, chapter 4. Read along. Yesterday I started reading along, but I had work to do, so I didn't. So today, I hope to put in the time and to do this. All right. Data structures, objects, and arrays. On 2 occasions, I have been asked, "Pray, Mr. Babbage, if you put into the machine wrong figures, will the right answers come out?" I am not able to rightly apprehend the kind of confusion of ideas that could provoke such a question. Charles Babbage. And I think I read that Charles Babbage was one of the founding fathers who made one of the computer machines that led to the birth of the modern computer. Here we have an image of a squirrel, some nuts, glasses, night sky, and some books. And you'll see soon why. Numbers, booleans, and strings are the atoms that data structures are built from. Many types of information require more than one atom though. Objects allow us to group values, including other objects, to build more complex structures. The programs we have built so far have been limited by the fact that they were operating only on simple data types. This chapter will introduce basic data structures. By the end of it, you'll know enough to start writing useful programs. Let me have my water just here. The chapter will walk through a more or less realistic programming example, introducing concepts as they apply to the problem at hand. The example code will often build on functions and bindings that were introduced earlier in the text. The were squirrel. Every now and then, usually between 8 p.m. and 10 p.m., Jacques finds himself transforming into a small, furry rodent with a bushy tail. On one hand, Jacques is quite glad that he doesn't have the classic lycanthropy. Turning into a squirrel does cause fewer problems than turning into a wolf. Instead of having to worry about accidentally eating the neighbor, that would be awkward, he worries about being eaten by the neighbor's cat. After 2 occasions where he woke up on a precariously thin branch on the crown of an oak, naked and disoriented, he has taken to locking the doors and windows of his room at night and putting a few walnuts on the floor to keep himself busy. That takes care of the cat and the tree problems. But Jacques would prefer to get rid of this condition entirely. The irregular occurrence of the transformation make him suspect that they might be triggered by something. For a while he believed that it happened only on days when he had been near oak trees, but avoiding oak trees did not stop the problem. Switching to a more scientific approach, Jacques has started keeping a daily log of everything he does on a given day and whether he changed form. With this data, he hopes to narrow down the conditions that trigger the transformations. The first thing he needs is a data structure to store this information. Datasets. To work with a chunk of digital data, we'll first have to find a way to represent it in our machine's memory. Say, for example, that we want to represent a collection of numbers 2, 3, 5, 7, and 11. We could get creative with strings. After all, strings can have any length, so we can put a lot of data into them and use open string 2, 3, 5, 7, 11 as our representation. But this is awkward. You'd have to somehow extract the digits and convert them back to numbers to access them. Fortunately, JavaScript provides data types specifically for storing sequences of values. It is called an array, and it is written as a list of values between square brackets separated by commas. For example, let list of numbers p open square bracket 2, 3, 5, 7, 11 close, and then console.log list of numbers, and then if you call 2, it will give you 5. So this is 0, 1, 2, it will give you 5. Console.log list of numbers 0, it will give you 2. Alright, let's write that in our pen. let list of numbers be open square brackets 2, 3, 5, 7, 11. Then we're going to close it. Then we're going to console.log, and then we're going to call list of numbers, and then we're going to call 2. And then let's see. Let's open the console. Uncaught list of numbers is not defined. All right. Clear. Is this the same thing? Always cool to notice the mistakes that I do when I'm reading JavaScript for the first time. Let list of numbers. I thought we have defined it, but let's come back to our notes. Let list of numbers. This is how they defined it also. Equals. Do we have an equals? Yes. Do we have a data structure, an array? Yes, we do. Alright, so while that takes a while to load, how about we just tried it in our developer tools. Alright, so it's gonna open developer tools, and we're going to alright, so we said let list of numbers be 2, 3, 5, 7, 11. These are prime numbers, and then close. Alright, and then we're going to, so it's undefined, console.log, and then we're going to list of numbers, and then we're going to ask for 2, then we're going to close it, and then we're going to close this one, then it's 5. So I know what I did wrong. What I did wrong, I not found. Is it the same thing that I wrote here? In our console? waiting for CodePen. List of numbers not defined. Clear. Alright, no problem. But we have found that it has given us 5 but still called undefined. Let's go back. Okay, the notation for getting the elements inside an array also uses square brackets. A pair of square brackets immediately after an expression with another expression inside them. We look up the element in the left-hand expression that corresponds to the index given by the expression in the brackets. That's a mouthful. The notation for getting at the element inside an array also uses square brackets. So okay, so the notation for getting elements inside an array also uses this square bracket. A pair of square brackets immediately after an expression with another expression inside them will look up at the element on the left-hand expression that corresponds to the index given by the expression in the bracket. So I think what they mean is, so a list of number 2 minus 1, it will go and say 0, 1, 2 minus 0, 1, and it will look at this, and therefore it will be 5 minus 2, which gives us 3. Alright, I think I understand that. The first index of an array is 0, not 1. So the first element is retrieved with list of numbers 0. Zero-based counting has a long tradition in technology and in certain ways makes a lot of sense, but it takes some getting used to. Think of the index as the amount of items to skip, counting from the start of the array. Properties. Well, we've seen a few suspicious looking expressions like myString.length to get the length of a string and math.max for the maximum function in past chapters. And myString.length would tell you the length of that string, and also this one math.max, it will output the maximum of maybe 2 or 3 different functions. In the past chapters, these are expressions that access a property of some value. In the first case, we access the length property of the value in my string. In the second, we access the property named max in the math object, which is a collection of mathematics related constants and functions, I think, that are built into JavaScript. Almost all JavaScript values have properties. The exceptions are null and undefined. If you try to access a property in one of the non-values, you get an error. What this means then is that this collection of mathematics related constants and functions that are built into JavaScript that um, um, have properties on every value in JavaScript, right? So null.length will be type error. The two main ways to access properties in JavaScript are with a dot and with square brackets. Both value.x and value square bracket x access a property on a value, but not necessarily the same property. Okay. The difference is how x is interpreted. When using a dot, the word after the dot is the literal name of the property. When using square brackets, the expression between the brackets is evaluated to get the property. So, whereas value.x fetches the property of the value named x, value square bracket x try to evaluate the expression x and use the result converted to string as the property name. Cool. I think here we can see immediately how it behaves in this example, that list of numbers 2, it will evaluate the 2 here and it will output 5. How did they explain it with their English? That whereas value.x fetches the property of the value named x, value square bracket x, for example, length.x, tries to evaluate the expression x and use the result converted to a string as the property name. So if you know that the property you are interested is called color, you say value.color. If you want to extract the property named by the value held in the binding I, you say value square bracket I. Property names are strings. They can be any string, but the dot notation works only with names that look like a valid binding names. So if you want to access a property named 2 or John Doe, you must use square brackets. Alright, let's read it again. If you know the property you're interested in is called color, say value.color. And if you want to extract the property named by the value held in the binding I, you say value square brackets I. Property names are strings. They can be any string, but the dot notation works only with names that look like valid binding names. So the dot notation will or work with things that look like valid binding names. So if you want to access the property named 2 or John Doe, you must use square brackets, value of 2 or value string John Doe. The elements in an array are stored as the array's properties using numbers as properties. names, as property names. Because you can't use the dot notation with numbers and usually want to use a binding that holds the index anyway, you have to use the bracket notation to get at them. The length property of an array tells us how many elements it has. This property name is a valid binding name, and we know its name in advance. So, find the length of an array. You typically write array.length because that's easier to write than array. Call it in square brackets length. So, for example, we can say array dot list of numbers, unquote error. Well, I don't know why. It should have told me 1, 2, 3, 4, 5. But let's find out in future why this did not work. All right. Back to here. Methods. Both strings and array values contain, in addition to the length property, a number of properties that hold function values. So let do be string do, console log, type of do dot to uppercase. It will give you what? A function. So let's try that in our pen. Let, was it lowercase? Do be string do. Close it. Alright. Let's clear here first. And then console.log type of, which is a function, type of do dot to uppercase. So let's let's try that. Console dot log open square brackets type of do, I think, to uppercase. Did I write it correctly? It's undefined. But let's just look at what mistakes I have done. Do dot to uppercase. It will give you a function. Alright. Console.log dot to uppercase. So now they're calling the to uppercase here as a function. Let me just try that here to call it as a function and see what happens. Do is not defined, and I wonder why. Did I not do it correctly? So let's try again, taking whatever we've written in CodePen and try and run it here. Do is not defined, and that should be a lesson on how to define bindings. So he said let do. Maybe it's because I used uppercase here. Would it have worked if it was lowercase? Let's try let do be string do. Close string and close it. It is undefined, but it exists. Then we're going to say console.log type of, which is a function, do dot uppercase to uppercase, then we're going to run it. It will tell me string. All right, it's told me string. Let's go back here, and it has given me do. I don't know if I did it wrongly. Okay. All right. So every string has a to uppercase property, and yeah, I think what should have happened, it when I called do dot to uppercase, I expect to have seen do turned into uppercase. You understand? Also the log type of do dot to uppercase, and I call it. I expected do, which I have defined as this string do, to become an uppercase string. Why that hasn't happened is something that I'm learning still. Let me copy this, Command C, and paste into my and then so it must have been my spelling or something. Right, Control C, and let's paste here, Control V. Do. All right, so let's compare. It's always good to look at our mistakes. So let do be do, and that's the same thing that he has done here. And immediately afterwards, he called console.log type of to uppercase. Is it possible to do it in? Is there a difference if you do it one by one? Right? I'm just trying to make sense to myself so I don't feel so stupid. So I'm gonna copy this only. This is an exercise in really understanding the JavaScript syntax. Is there a way to clear? There used to be a way to clear. All right, let me just paste first. Undefined. So what happens is if you write it one at a time, it runs it one at a time. Control C, Control V. It runs this. So it. All right. So I wasn't so very wrong. I must just have. If I wanted to get this, I should have typed them on and run it together. And I wonder why that happens. But we'll find out. That's why we're learning JavaScript. So every string has a to uppercase property. When called, it will return a copy of the string in which all letters have been converted to uppercase, like do. Alright, there's also a to lowercase going the other way. Interestingly though, the call to uppercase does not pass any arguments. The function somehow has access to the string do, the value whose property we called. How this works is described in chapter 6. Properties that contain functions are generally called methods of the value they belong to, as in, to uppercase is a method of a string. This example demonstrates two methods that you can use to manipulate arrays. Okay, so let sequence be open square bracket 1, 2, 3. Let sequence be this array of 1, 2, 3. And then sequence dot push in bracket 4, close it. Sequence dot push 5, then close it. Then console dot log sequence, it will give you 1, 2, 3, 4, 5. So I think they've introduced two new methods, which is push. Or actually, it's push. What am I thinking? It's two. It's two. So it's push. So let me try that in my code editor here. All right. So we said let sequence be and we're going to open an array 1, 2, 3, 3. Then we're going to close it, and then I want, when I hit enter, to start writing sequence dot push 4, and then close it, and then I want to copy this, command C, enter, command V, and then I want to turn this to 5, and then I want to call it in the console.log, console.log sequence. Is this the same way they've done it? Have I messed the syntax? Alright, yay! Object array 1, 2, 3, 4, 5. So we've added 4 and 5. I was getting pretty nervous. Alright, and just let me look at it load. Give me 5. Come on. Nothing? Alright, let's go back and read. So console.log sequence pop. So what is this? Sequence pop. It will give you sequence.pop, it will give you 5. So console.log sequence, and it will give you 1, 2, 3, 4. So the push method adds values to the end of an array, and the pop method does the opposite by removing the last value in the array and returning it. So when I pop this sequence, it will tell me it's going to pop 5. And then when I console log my sequence, it will only give me 1, 2, 3, 4, as it has popped 1 out. Oh, okay, that's cool. Let's try that on our pen. All right. So what did they do? He said console console.log sequence dot pop, and then function pop native code. So what happens now? So it's sequence dot pop. All right, and then let's say console.log, and we're going to sequence. Let's see what it will give us. All right, so when we pop, we've popped 5, and then when we call for the sequence now as it is, it will only give us 4. We've learned that. Okay, that's good. So all right, let's read again. The push method adds values to the end of an array, and the pop method does the opposite, removing the last value in the array and returning it. These somewhat silly names are traditional terms for operations on a stack. A stack in programming is a data structure that allows you to push values into it and pop them out again in the opposite order, so that the thing that was added last is removed first. These are common in programming. You might remember the function call stack in the previous chapter, which is an instance of the same idea. Objects. Back to the weird squirrel. A set of daily log entries can be represented as an array, but the entries do not consist of just a number of string. Each entry needs to store a list of activities and a Boolean value that indicates whether Jackis turned into a squirrel or not. Ideally, we'd like to group this together into a single value and then put those group values into an array of log entries. Values of the type object are arbitrary collections of properties. One way to create an object is by using braces as an expression. Alright, so let's do that again. And here is in our example, a set of daily log entries can be represented as an array. Okay, so Monday, Tuesday, Wednesday, Thursday, I guess, or day 1 here is how they try to do day 1, day 2. But entries do not consist just a number or a string. Each entry needs to store a list of activities. Alright, so it's day 1 and is 8 nuts and turned into squirrel. Day 2, 8 nuts went near an oak tree, turned into a squirrel. So those are a list of values and a boolean value that indicates whether Jack is turned into a squirrel or not, and then it will be turned into a squirrel true, okay, or turned into a squirrel false. So ideally, would like to group this together into a single value and put those grouped values into an array of log entries. All right. So values of the type object are arbitrary collections of properties. One way to create an object is by using braces as an expression. So let day 1 create an object. So it's going to create an object squirrel false, so it did not turn into a squirrel. And then the events in an array: work, touch tree, pizza, running. Console day 1 squirrel, it will tell us false. Alright, console.log day 1.wolf, it will tell us unidentified. And then we say day 1.wolf, it will give us false. Then when we say console log day 1.wolf, it will also give us false. Let's look at this code again and try to understand it. He said that let day 1, and then he created a function. This is really cool because now we are getting into learning about functions. Okay, so delete and then clear. So he said let day 1 be, and then opened a function. Okay, and then he said squirrel, is that the spelling, is false. And then what did he say? So here so let's just look yeah, so the right spelling. Okay, so we don't close it, we have to put a comma. All right, so this is these are the objects squirrel and events. All right, so that was all right. Then let's say events, and then what he did was events opened a square bracket, and then there were a bunch of strings in here. So let's just confirm. He went to work, touched a tree, had pizza, and did running. All right. Went to work. Okay, comma, touched a tree, comma, had pizza, comma, and did a bunch of, oh yeah, let's put it in a string, did a bunch of running. All right, and then we're going to, when are we closing this one out? We're closing it at the end of the object. All right, so now that we've defined this event in an object, I said let's look at let's create what did we call this here? Method. All right, a method called squirrel in day 1. All right, so let's see if that one works. Let's just clear console.log row. Let's see what console log will tell us. Undefined. Oh man. And let's paste this into our command C. And I wonder how you can clear this. Can you just say clear? And it will clear. Nothing? Alright. Ah, invalid. Alright, so maybe I'm the one who's wrong. Maybe it's what am I missing? Day one dot squirrel. Let day one be squirrel false, then events work touched a tree, pizza running, then close our object, then run console.log day one dot squirrel. I must have missed something. Alright, okay, so let's copy this code. Always cool to just compare our syntax that we are failing in with the syntax that has been given in the example. It said false but also said undefined, so let's look at ours. Where did we go wrong? Okay, spelling. First of all, my spelling is off, but I have just spelled the same way I spelled here. Here squirrel has double R and one L. So let day one be squirrel false. Let day one be squirrel wrong false, and then the events. Oh, so here's something I also didn't do. I did not have. Alright, so I did not have. So I used equals instead of this. It's so obvious now that I look back, but I'm learning the syntax and that's okay. And now that I do that, it will reload and it will tell me false. So what have I learned from making that mistake? That when you're writing an object, you don't define another string. Equals defines, or equals creates bindings. Remember, do not create binding unless that's what you want. That's a good lesson to learn. It has given us false, but console.log day one wolf is unidentified, and then we tell it, we define that day one wolf is false, and then we ask it, tell me day one wolf, and it will tell me false. Inside the braces, there is a list of properties separated by commas. Each property has a name followed by a colon and a value. A colon and a value, that's why you went wrong, John. When an object is written over multiple lines, indenting it, like in the example, helps with readability. Properties whose names aren't valid, binding names or valid names, have to be quoted. So like went to work, touched a tree, those have to be quoted because they are not valid binding names. This means that the braces have two meanings in JavaScript. Alright, this is some important information. At the start of the statement, they start a block of statements. In any other position, they describe an object. Alright. Fortunately, it is rarely useful to start a statement with an object in braces, so the ambiguity between these two is not much of a problem. We have two meanings. Braces have two meanings in JavaScript. At the start of a statement, they start a block of statements. In any other position, they describe an object. So, an example would be like if you're saying if. So I think an example is, for example, you say if, and you have this, then um, you have a bunch of braces. This is not an object. It defines, it starts a block of statements. So there are going to be a bunch of statements in here. But any other place, like in the beginning, it becomes an object. All right. Cool. Reading a property that doesn't exist will give you the value of undefined. That's another thing about JavaScript. It is possible to assign a value to a property expression with the equals operator. So this will replace the property's value if it already existed, or create a new property on the object if you didn't find it. So an example here is when we tried to look for the one.wolf, it was undefined. And then the equals defined the one.wolf as false. To briefly return to our tentacle model of bindings, property bindings are similar. They grasp values, but other bindings and properties might be holding on to the same values. You might think of objects as octopuses with many number of tentacles. Each has a name tattooed on it. The delete operator cuts off a tentacle from such an octopus. It is a unary operator that, when applied to an object property, will remove the name property from the object. This is not a common thing to do, but it is possible. For example, let an object, then going to create an object with the braces be left 1 and right 2. Console.log an object left, it will give you 1. Delete an object left. So delete is going to work as a unary operator that removes that binding, it removes that tentacle. Okay. Console.log an object left, it comes back to undefined. When you say console.log left in an object, it will tell you false because it no longer exists. But when you ask right in an object, it tells you true. The binary in operator, when applied to a string and an object, tells you whether that object has a property with that name. The difference between setting a property to undefined and actually deleting it is that in the first case, the object still has the property. It just doesn't have very interesting value. Whereas in the second case, the property is no longer present and in will return false. To find out what property an object has, you can use the object.keys function. You give it an object and it returns an array of strings, the object's properties names. For example, we can say console.log function object.keys, and then we're going to look inside, we're going to run the function x, y, and z. Then it will give us back x, y, z. Right. There's an object assign. That's another one that exists in JavaScript. There's an object assign function that copies all properties from one object to another. So let object A be, we start our function, A is 1 and B is 2, close our function. So object assign, and then object A, going to open another function, B is 3 and C is 4. So console.log object A, going to have A is 1, B is 3, C is 4. Alright, that's cool. Alright. Arrays then are just a kind of object specialized for storing sequences of things. If you evaluate the type of square brackets, it produces object. You can see them as long, flat octopuses with all their tentacles in a neat row labeled with numbers. We will represent the journal that Jacques keeps as an array of objects, right? So let journal, I'm going to open array. In the array, we're going to create an object called events. In the events, we're going to have a bunch of array, work, touch tree, pizza, running, watch television, and squirrel is false, comma, another event, another function, events, work, ice cream, cauliflower, lasagna, touch tree, brush teeth, squirrel, false. Close that one, comma. Another object, events, going to have weekend, cycling, break, peanuts, and beer, squirrel, true, and so on. All right, cool. That is actually really cool to learn. And then finally, we're going to close our array. Okay, so this is an array with a bunch of objects that have arrays that you can call. Mutability. We will get to actual programming real soon now. First, there's one more piece of theory to understand. We saw that object values cannot be modified. The type of values discussed in earlier chapters, such as numbers, strings, and booleans, are all immutable. Immutable. What does that mean? It is impossible to change the values of those types. Let's read that again. What we saw that object values cannot be modified. The type of values discussed in earlier chapters, such as numbers, strings, and booleans, are immutable. It is impossible to change values of those types. You can combine them and derive new values from them, but when you take a specific string value, that value will always remain the same. The text inside it cannot be changed. If you have a string that contains cat, it is not possible for other code to change that character in a string and make it spell rat. Objects work differently. You can change their properties, causing a single object value to have different content at different times. When we have two numbers, 120 and 20, we can consider them precisely the same number, whether or not they refer to the same physical bits. With objects, there is a difference between having two references to the same object and having two different objects that contain the same property. Consider the following code. Let object 1, and we're going to create an object called value and give it 10. And then let object 2, and we're actually going to create a binding and call it object 1. And then let object 3 be, and we're going to create each an object of value 10. Console.log object 1 is the same as object 2. It will give you true. Object 1 is the same as object 2. It will give you true, because technically we've given this binding. But console.log object 1 is the same as object 3. It will give you false. As much as the value are the same, these are not similar objects. So object 1.value is 15. Console.log object 2's value, it will also give you 15. We have continued our statements and we have built a new binding. Then console.log object 3.value, it will still give you 10. Alright, so objects are not necessarily the same, even though they might have the same value. The object 1 and object 2 bindings grasp the same object, which is why changing object 1 also changes the value of object 2. They are said to have the same identity. The binding object 3 points to a different object which initially contains the same properties as object 1 but lives a separate life. Okay? Bindings can also be changeable or constant. But this is separate from the way their values behave. Even though number values don't change, you can use a let binding to keep track of a changing number by changing the value of the binding points at. Similarly though, a const binding to an object can itself not be changed and will continue to point at the same object. The contents of that object might change. So here they have told us now about const, we knew about let, we also heard of var. So const score, we're going to create an object and call it visitors, and we're going to have 0 and home is going to be 0. We're going to say this is okay. And then store score.visitors, we're going to give it 1. Score of visitors, we're going to give it 1. It will tell us this isn't allowed. Score equals visitors 1, home 1. Okay. When you compare objects with JavaScript's double equal operator, it compares by identity. It will produce true only if both objects are precisely the same value. Comparing different objects will return false, even if they have identical properties. There is no deep comparison built into JavaScript, which compares objects by contents. But it is possible to write yourself, to write it yourself, which is one of the exercises at the end of this chapter. All right. The lycanthropy log. All right. So now that we have that theory, so Jackie starts his JavaScript interpreter and sets up the environment he needs to keep his journal. So he says let journal be an array. Okay. Function, going to create a function called add entry. In add entry, he will have events and squirrel, and then he will create inside that a journal.push, which in it will have events and squirrel. Okay, so now we are combining everything that we've been learning from the syntax to functions and objects. Note that the object added to the journal looks a little odd. Okay, instead of declaring properties like events, it just gives a property name. This is shorthand that means the same thing. If a property name in brace notation isn't followed by a value, the value is taken from the binding with the same name. Alright, so the value here of events is taken from events, and the value here of squirrel is taken from squirrel, or it could have been journal.push. Alright, I don't entirely understand that yet, but that's okay. Okay, so then everything at 10 p.m. So then every evening at 10 p.m. or sometime the next morning, after climbing down from the top shelf of his bookcase, Jackie records the day. Add entry. Then he's going to add an array: work, touch, tree, pizza, running, television, false. And this first part will refer to events. And this second part will refer to squirrel. Okay. Then add entry, work, ice cream, cauliflower, lasagna, touch tree, brush teeth. It will refer to events. And then false will refer to squirrel. I think I get it now a little bit. It's becoming less fuzzy. Add entry. This is the third one. Weekend, cycling, break, peanuts, beer will refer to events, and true will refer to turning into a squirrel. Once he has enough data points, he intends to use statistics to find out which of these events may be related to the squirrelifications. Correlation is a measure of dependence between statistical variables. Correlation is a measure of dependence between statistical variables. So the correlation A and B. A statistical variable is not quite the same as a programming variable. In statistics, you typically have a set of measurements, and each variable is measured for every measurement. Correlation between variables is usually expressed as a value that ranges from -1 to 1. Zero correlation means the variables are not related. A correlation of 1 indicates that two are perfectly related. If you know one, you also know the other. -1 also means that the variables are perfectly related, but they are opposites. When one is true, the other is false. To compute the measures of correlations between two Boolean values, we can use the Phi coefficient. This is a formula whose input is a frequency table containing the number of times the different combination of variables were observed. The output of the formula is a number between -1 and 1 that describes the correlation. We could take the event of eating pizza and put that in a frequency table like this, where each number indicates the amount of times that combination occurred in our measurements. No squirrel, no pizza, 76. No squirrel, pizza, 9. Squirrel, no pizza, 4. Squirrel and pizza, 1. If you call the table n, we can compute the phi coefficient using the formula for a following formula. Phi equals interesting number here. So here's a quote. If at this point you're putting the book down to focus on a terrible flashback to 10th grade math class, hold on. I do not intend to torture you with endless pages of cryptic notation. It's just one formula for now. And even with this one, all we do is turn into JavaScript. The notation n, I don't know, the opposite of how can I say it? How do you call 2 to power of 2? Like, there has to be a word. Yeah, I forget. There's a exponent. So what is the opposite of exponent? What is the inverse of an exponent? Is exponent n as a radical? But how can I say it? Inverse exponent. I guess that's how do you what is the bottom exponent called? The base, the number suggests there's the number a small number in the subscript called the exponent. I guess it's called an exponent. I don't know, man. Let's come back and try and understand this math. Whew, that was a little bit scary there. The notation n base inverse exponent 0, 1 indicates the number of measurements where the first variable squirrelness is false, 0, and the second variable pizza is true, 1. In the pizza table, n inverse exponent 0, 1 is 9. So the value of n1, this, refers to the sum of all measurements where the first variable is true, which is 5 in the example table. Likewise, n inverse exponent 0 refers to the sum of the measurements where the second variable is false. So, for the pizza table, the part above the division line, the dividend, would be 1 times 76 minus 4 times 9, which is 40. And the part below it, the divisor, would be the square root of 5 times 85 times 10 times 80, or the square root of 340,000. This comes out to phi 0.069, which is tiny. So eating pizza does not appear to have influence on the transformations. Computing correlation. So here they have used math, I guess. They have used like real math and statistics to find that the phi coefficient is actually here 0.069. So it's very tiny and does not have an influence on our squirrelization. Alright, so let's compute it. So we can represent the 2 by 2 table in JavaScript with a 4-element array, which is 76, 9, 4, and 1. And we could use other representations such as an array containing a 2-element arrays. So an array of an array, 76 and 9, 4 and 1. Or an object with the property names like 11 and 0, 1. But the flat array is simple and makes the expression that is access the table pleasantly short. So we'll interpret the indices to the array as 2-bit binary numbers, where the leftmost, that is most significant digit, refers to the squirrel variable, and the rightmost, that is the least significant digit, refers to the event variable. So for example, the binary number 10 refers to the case where Jacques did turn into a squirrel, but the event, say, pizza, didn't occur. This happens 4 times, and since binary 10 is 2 in decimal notation, we will store the number at index 2 of the array. Alright, so this is the function that computes the phi coefficient from such an array. So here, technically, they're turning this mathematic statistical coefficient into a computed code. So we said function phi of table, and the function phi, we're going to have an object, and the object will say return table 3 times table 0 minus table 2 times table 1. What does this mean? What does this property mean? I totally forget. Property in JavaScript. I don't think it's the word. I think it's not a word. I think you say operator in JavaScript. Oh, I don't have internet connection. Come on, man. Let's go to google.com, or maybe it read it as a file instead of a what is operator in JavaScript. So maybe it doesn't have, maybe it's actually over, maybe it means over, right? Maybe it means that over math dot square root and then going to have a bunch of them here. Table 2 plus table 3, table 0 plus table 1. Oh, I had blackouts there. Table 1 plus table 3, table 0 plus table 2. Then console.log Phi coefficient 76, 9, 4, and 1, and you'll actually get this. And I think I really just need to work this, because I kind of understand how they've gotten there, but I don't understand how they've computed this. But it's cool to know that you can turn math into JavaScript. So this is the direct translation of the phi formula into JavaScript. Math.square root is the square root function as provided by the math object in standard JavaScript environment that's built into JavaScript. We have to add two fields from the table to get a field like n inverse power 1, because the sums of rows or columns are not stored directly in our data structure. Alright, Jekis kept his journal for 3 months, and the resulting data set is available in the coding sandbox for this chapter, where it is stored in the journal binding in a downloadable file. Right. Do we have our Wi-Fi back? Let's find out. Highlight out. But let's look at that code. As our Wi-Fi connects because of our blackout, let's go back. To extract a 2x2 table for a specific event from the journal, we must loop over all the entries and tally how many times the event occurs in relation to squirrel transformations. So I'm going to create a function and call it table4, and it's going to have event and journal as our function. And inside you're going to pass the statements, the following statements, and then we're going to have a let table. We have an array here, and then for going to start a loop. Let I be 0, but I should be less than journal length. Then add. Then going to close that, open another object. If entry.events includes event index plus 1, and if entry.squirrel is the index plus or equals to 2, table index is equal to plus or 1, return table. So console log table for pizza journal will give us 76, 9, 4, and 1. Cool. All right. So arrays have an includes method that checks whether a given value exists in the array. The function uses that to determine whether the event name it is interested in is part of the event list for a given day. The body of the loop in table 4 figures out which box the table each journal entry falls into by checking whether the entry contains the specific event it is interested in and whether the event happens alongside the squirrel incident. That's the table 4 function, right? Method. The loop then adds 1 to the correct box in the table. Wow. So we now have the tools we need to compute individual correlations. The only step remaining is to find a correlation for every type of events that was recorded to see whether everything stands out. Array loops. In the table 4 function, there's a loop like this. for let I be 0, but I should be less than journal length. Then I'm going to add. Then let entry be journal of the array I. Do something with entry. Interesting. So this is called an array loop. This kind of loop is common in classical JavaScript. Going over arrays one element at a time is something that comes up a lot. And to do that, you'd run a counter over the length of the array and pick out each element in return. There's a simpler way to write such loops in modern JavaScript. Alright. I forget what this is called. So for let entry of journal, and then going to run the following statements inside it. Console.log entry.events. What does this? Is my internet back though? Let's find out. Oh no. It's whatever. I don't have to. Entry.events length and events, and then it will give us. When a for loop looks like this with the word of after a variable definition, it will loop over the elements of the value given after of. This works not only for arrays but also for strings and some other data structures. We'll discuss how it works in chapter 6. The final analysis. We need to compute a correlation for every type of event that occurs in the dataset. To do that, we first need to find every type of event. Okay, so we need to compute a correlation for every type of event that occurs in the dataset. And to do that, we need to find every type of events. Okay, so function journal events of a journal, and inside we're going to have let events be an array for let the entry of the journal going to pass in the statement for let event of entry.events going to pass in other statements if not event includes event. That's our boolean. It has to pass true or false, and then event push an event, then return events. Console log journal events journal, you'll find carrot, exercise, weekend, bread. By going over all the events and adding those that aren't already in there to event arrays, the function collects every type of event. Using that, we can see all the correlations. For example, for let event of journal events journal, going to pass in console.log event plus what do you call it, colon string, and then phi table for event journal. So it will give us carrot 0.1, exercise 0.6, weekend 0.13, bread 0.7, pudding 0.6, and so on. Alright, so most correlations seem to lie close to 0. Eating carrots, bread, or pudding apparently does not trigger squirrel lycanthropy. It does not seem to occur. It does seem to occur more often on weekend. So let's filter the result to only show correlations greater than 0.1 and less than negative 0.1. Alright, so we are building more logic into our program. So for let event of journal events journal, we're going to pass this statement. So let correlation be phi table for event journal if correlation is greater than 0.1 or correlation is less than 0.1. Then if that's true, give me console.log event plus apostrophe and correlation. It will give me weekend 0.13, brush teeth 0.3, which is actually higher, candy 0.12, work 0.13, spaghetti 0.24, reading 0.11, peanuts 0.59. Bruh, peanuts is the higher. Aha! There are two factors that correlate that's clearly stronger than the others. Eating peanuts has a strong positive effect on a chance of turning into a squirrel, whereas brushing his teeth has a negative effect. Interesting, interesting. Let's try something. 4. Let entry of journal if entry.event includes peanuts, and so we want to get entry of journal if we're going to pass the statements. Entry of events include peanuts, and it's our logical AND operator. Not events includes brush teeth. Entry.events push peanut teeth. Close out, then close that statement. Console.log, blackout. Phi table for peanut teeth and journal give us 1. Bruh! That's a strong result. Let's see if I can still see myself. Significantly darker. But let me just keep going for a few more minutes because I don't want to break the flow. Okay, that's a strong result. The phenomenon occurs precisely when Jacques eats peanuts and fails to brush his teeth. Ha! If only he weren't such a slob about dental hygiene, he'd never noticed this affliction. Knowing this, Jackie stops eating peanuts altogether and finds that his transformations don't come back. For a few years, things go great for Jackie, but at some point he loses his job. Because he lives in a nasty country where having no job means having no medical services, he is forced to take employment with the circus where he performs as the incredible Squirrel Man, stuffing his mouth with peanut butter before every show. One day, fed up with his pitiful existence, Jackie fails change back into his human form, hops through a crack in the circus tent, and vanishes into the forest. He is never seen again. I like that story. Before finishing the chapter, I want to introduce you to a few more object-related concepts. I'll start by introducing some generally useful array methods. So we saw push and pop, which add and remove elements at the end of an array earlier in the chapter. The corresponding methods for adding and removing things at the start of an array are called unshift and shift. So let's look at it. Let to-do list be an array function, remember task. Then in this function, this function called remember, that's going to have task, and we're going to pass in the following parameters: to-do list dot push on task. See how I've gotten better at reading code, reading JavaScript code. Function get task, and then inside it we're going to pass return to-do list dot shift. then call it, close, step out of it. Function, remember urgently, task. Inside, we're going to pass to-do list, then unshift task. That program manages a queue of tasks. You add a task at the end of the queue by calling remember groceries. And when you're ready to do something, you call a get task function and get and remove the front item from the queue. The remember urgently function also adds a task but does it to the front instead of the back of the queue. So to search for a specific value, arrays provide an index of method. The method searches through the array from the start to the end and return the index at which the requested value was found, or -1 if it wasn't found. So to search from the end instead of the start, there's a similar method called last index of. And it seems to me as methods are a cool thing to study in JavaScript. So console.log, open the array 1, 2, 3, 2, 1 dot index of 2. What does it do? It searches that 2 and tells me it's at place 1. Alright. Console.log 1, 2, 3, 2, 1 dot last index of 2. It will tell me 3. So 0, 1, 2. It will start from the end. Cool, but it will still use the 0-based counting. So this is 0, 1, 2. So last index of 2 is 0. Alright, cool. So 0, 1, it will give me 1. And last index of 2. So 0, 1, 2. That's interesting because it seems like two different things, but index of and last index of take an optional second argument that indicates where to start searching. Another fundamental array method is slice, which takes start and end indices and return an array that has only the elements between them. The start index is inclusive, the end index exclusive. Console.log, we have 0, 1, 2, 3, and 4. Then slice 2 and 4. It will give us 2 and 3. Console log 0, 1, 2, 3, 4, but slice 2. It will give me 2, 3, and 4. When the end index is not given, slice will take all of the elements after the start index. You can also omit the start index to copy the entire array. The concat method can be used to glue arrays together to create a new array, similar to what the plus operator does for strings. The following examples show both the concat and slice in action. It takes an array and an index and returns a new array that is a copy of the original array with the elements at the given index removed. Okay. So function remove array and index, we're going to pass in return array.slice 0 index, then concat array.slice and index plus 1. Console.log remove a, b, c, d, e, and 2. It will give me a, b, d, e. Oh, cool. It was removed. 0, 1, 2. If you pass concat an argument that's not an array, the value will be added to the new arrays as if it was a one-element array. strings and their properties. Cool. We can read properties like length and to uppercase from string values. But if you try to add a new property, it doesn't stick. Okay. So example, let Kim be Kim. And Kim age is 88. Console log kim.age undefined. Huh. Interesting. Values of type string, number, and boolean are not objects, and though the language doesn't complain if you try to set a new property on them, it doesn't actually store those properties. As mentioned earlier, such values are immutable and cannot be changed. But these types do have built-in properties. Every string value has a number of methods. Some very useful ones are slice and index of, which resemble the array methods in the same name. So for example, coconut slice 4 and 7, it will slice, it will give me nut. So it will slice, let's see, it will slice 4. How does that look like? I don't know. I don't know. Will it count? 1, 2, 3, 4. So it will count the length. So dot length, and then it will slice 4, and s will give me nut. Cool. And then when I say console.log coconut, the string, and then index of u, it will count for me, and with the length property give me. So one difference is that a string's index of can search for a string containing more than one character, whereas the corresponding array method looks only for a single element. Console.log 1, 2, 3, index of a 11, right? How come? One difference that strings index of can search for a string containing more than one character, whereas the corresponding array method looks for only a single element. I did not understand this. The trim method removes white space, so spaces, new lines, tabs, and characters from the start and end of a string. So console.log okay, and then I think this is this enter to give me a new paragraph, trim, and run that function, that method as a function, and just give me okay. The zero pad function from the previous chapter also exists as a method. It is called padStart and takes the desired length of the padding characters as arguments. So console.log string 6 padStart 3 0, and it will give me 006. You can split a string on every occurrence of another string with a split, and you can join them again with join. Let sentence secretary bird specialize in stomping be okay, fine. So let the sentence be secretary bird specialize in stomping. Then let words be sentence dot split and create a it's going to be a string of a quote. So console.log words, it will give us right. So it's going to add the words in sentence. So secretary birds specialize in stomping. Console log words dot join quote and full stop then close it. Secretary bird specialize in stomping. Cool. A string can be repeated with the repeat method, which creates a new string containing multiple copies of the original string glued together. Console.log la.repeat 3 give me la la la. We have already seen the string's length type property. Accessing the individual characters in a string looks like accessing array elements with a caveat. We'll discuss this in chapter 5. Woo! Let's string abc console.log string.length, it will give me 3. Console log string array 1, it will give me b. Rest parameters. It can be useful for a function to accept any number of arguments. For example, math.max computes the maximum of all the arguments it is given. To write such a function, you put 3 dots before the function's last parameter like this. Function max dot 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 numbers. Run the following parameters. Let result be infinity minus infinity. For let number of numbers, if number is more than result and result is number, return result. So console.log max of 4, 1, 9, n minus 2, it will give me 9. When such a function is called, the rest parameter is bound to an array containing all further arguments. If there are other parameters before it, the values aren't part of that array. When, as in max, it is the only parameter, it will hold all arguments. You can use a similar 3-dot notation to call a function within an array of arguments. Let numbers 5, 1, 7, then log max to get the max dot 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 numbers. It gives you 7. That's another way to make it less verbose. This spreads out the array into the function call, passing its elements as separate arguments. It is possible to include an array that is along with other arguments, as in max 9 dot 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 numbers and 2. Square bracket array notation similarly allows the triple dot operator to spread another array into the new array. So let words be an array of never and fully. Console.log will dot 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 max words understand. It will give you will never fully understand the math object. As we've seen, math is a grab bag of number-related utility functions such as math.max, which is the maximum, math.min, which is the minimum, and math.square root, which is the square root. The math object is used as a container to group a bunch of related functionality. There's only one math object, and it is almost never useful as a value. Rather, it provides a namespace so that all these functions and values do not have to be global bindings. Having too many global bindings pollutes the namespace. The more names have been taken, the more likely you are to accidentally overwrite the value of some binding. For example, it is not unlikely you'll want to name something max in one of your programs. Since JavaScript's built-in max function is stacked safely inside the math object, we don't have to worry about overwriting it. Many languages will stop you, or at least warn you when you are defining a binding with a name that is already taken. JavaScript does this for bindings you declared with let or constant, perversely not for standard bindings nor for bindings declared with var or function. Back to the math object. If you need to do trigonometry, math can help. It contains cos, which is cosine, and sin, which is sine, and tan, tangent, as well as other inverse functions, a cos, a sine, and a tan, respectively. The number pi, or at least the closest approximation that fits in a JavaScript number, is available as math.py, which is an old programming tradition of writing names of constant values in all caps. So, function of a random point on a circle of radius, we're going to pass in the following parameters. Let angle be math.random times 2 math.py. Return an object x is radius times math.cosine angle and y is radius times math.sine angle. Then console.log random point of a circle 2. It will give me that x is 0.3667, y is 1.966. If the sines and cosines are not something you're familiar with, don't worry. When they are used in this book, in chapter 14, I'll explain them. The previous example used is math.random, which is a function that returns a new pseudo-random number between 0, inclusive, and 1 that's exclusive every time you call it. So console.log math.random, and it will give me that number. Yeah, very interesting. Console.log math.random will give me that number. So though computers are deterministic machines, they always react the same way given the same input. It is possible to have them produce numbers that appear random. To do that, the machine keeps some hidden value, and whenever you ask for a new random number, it performs complicated computations on this hidden value to create a new value. It stores a new value and returns some number derived from it. That way, it can produce ever new, hard to predict numbers in a way that seems random. If you want a whole random numbers instead of a fractional one, we can use math.floor, which runs down the nearest whole number as a result of math.random. So console.log math.floor and math.random times 10, just give me 2. Multiplying the random number by 10 gives us a number greater than or equal to 0 and below 10. Since math.floor runs down, this expression will produce with equal chance any number from 0 through 9. There are also functions math.ceil for ceiling, which rounds up to a whole number, math.round to the nearest whole number, math.abs, which takes the absolute value of a number, meaning it negates negative values but leaves positive ones as they are. Alright, destructuring. And I need to be winding up. Let's see how far I have to go. Alright, so I'm going to start from destructuring. Or maybe, no, actually I'm done. Let's go back to the phi function for a moment. Function phi table, and this, one of the reasons this function is awkward to read is that we have a binding pointing at our array, but we'd much prefer to have bindings for the elements of the array. That is, let n 0 0 be table 0 and so on. Fortunately, there's a succinct way to do this in JavaScript. Function phi n00, n01, n10, so this is our array, and return n11 times n00 minus n10 times n01 over mod square root of this thing. This also works for bindings created with let, var, or const. If you know the value you are binding is an array, you can use the square brackets to look inside of the value binding its content. A similar trick works for objects using braces instead of square brackets. So let object name be name Faraji age 23. Console log name Faraji. Now that if you try to destructure null or undefined, you get an error, much as you would if you directly try to access a property of those values. Json. Because properties only grasp their value rather than contain it, objects and arrays are stored in the computer's memory as sequences of bits holding the addresses the place in memory of their content. So an array with another array inside it, instead of it, consists of at least one memory region for the inner array and another for the outer array, containing, among other things, a binary number that represents the position of the inner array. If you want to save data in a file for later or send it to another computer over the network, you have to somehow convert these tangles of memory addresses to a description that can be stored or sent. You could send over your entire computer memory along with the addresses of the value you're interested in, I suppose, but it doesn't seem like the best approach. What we can do is serialize the data. That means it is converted into a flat description. A popular serialization format is called JSON, pronounced JSON, which stands for JavaScript Object Notation. It is widely used as a data storage and communication format on the web, even in languages other than JavaScript. JSON looks similar to JavaScript's way of writing arrays and objects with a few restrictions. All property names have to be surrounded by double quotes, and only simple data expressions are allowed. No function calls, bindings, or anything that involves actual computation. Comments are not allowed in JSON. A general entry might look like this when represented as JSON data. Open object, squirrel, false. Then events, work, touch tree, pizza, running, and then close. JavaScript gives the function json.stringify and json.parse to convert data to and from this format. So it's probably written into JavaScript. The first takes a JavaScript value and returns a JSON encoded string. The second takes such a string and converts it to the value it encodes. So let string be json.stringify, squirrel, false, offense, weekend, console log the string. It will give me this JSON data. Console log json.parse string and events. It will give me weekend. And finish. Objects and arrays, which are kind of a specific kind of object, provide ways to group several values into a single value. Conceptually, this allows us to put a bunch of related things in a bag and run around with the bag instead of wrapping our arms around all the individual things and trying to hold them separately. Most values in JavaScript have properties, the exception being null and identified. Properties are accessed using value.prop or value prop in square brackets. Objects tend to use names for their properties and store more or less a fixed set of them. Arrays, on the other hand, usually contain a varying amounts of conceptually identical values and use numbers starting from 0 as the names of properties. There are some name properties in an array, such as length and number of methods. Methods are functions that live in properties and usually act on the value they are a property of. You can iterate over an array using a special kind of for loop, which is for let element of array. That was the summary of arrays. That was really cool. It was so dense, and something I'd like to go back to. And now we'll go and look at the exercises in the next lesson. All right.